principle of multiple protection layers has been illustrated in various diagrams in different reference books. This one is similar to the one depicted in IEC 61511 Part 3, but with some subtle differences. Firstly, note that some layers are clear prevention barriers, as they can potentially stop a hazardous event from occurring. These are shown with solid outlines. The remaining layers with dotted outlines are for mitigation of events after one or more prevention layers has failed. In LoPA, we can consider both of these types of layer, but generally speaking the focus should be primarily on prevention of hazard escalation. Here we can consider a simple LoPA example to see how the principle works. The scenario begins with an initiating event, in this case a pump failure. There's often some time for response before an undesired outcome occurs. Assuming the pump failure leads to an event which is loss of cooling, resulting in a vessel rupture, if there are no protection layers, that event will happen at the same frequency of the pump failure. If we consider an operator response to a high temperature alarm as an independent protection layer, we can then see that no event will occur if that operator response is successful. However, in LoPA we're interested in the frequency of the undesired event, so what we look at is the failure of the operator rather than the success. Taking that failure to be 1 in 10 or a probability of failure of 0.1, the occurrence then will be whatever the initiating event frequency was multiplied by that probability of failure. This works in the same way for all protection layers, provided they are truly independent of the initiating event and all other protection layers